2212 Lab 1, and the purpose of this lab is to observe the interactions between two pieces of charged tape. We also want to see if there's an electron deficit or excess on the tapes. And starting off our fundamental physics principles, we have the momentum principle, which says that F net is equal to dp over dt, and this is basically needed to help say that the forces balance each other out. And the force of gravity is one of the forces we deal with, which on Earth, the constant is 9.8 meters per second squared, and the force of gravity universally is equal to negative g times mass 1 times mass 2 over the distance squared times r hat. The second force we will need to deal with is the electric force given to us by Coulomb's law, which is equal to the constant k shown on screen times charge 1 times charge 2 over the distance squared times r hat. And we will use a model that included tape, a flat surface, a ruler, and objects to hold the tape up for the experiment. And we also had a glow script model, and for our brief preview, we found that the charge of each tape was 9.3 times 10 to the negative 9 coulomb, and then the amount of electrons lost was roughly 5.83 times 10 to the 10 electrons, and the tape had a positive charge. Our system, which we will call tape B, was the piece of tape that was floating, and the surroundings include everything else, such as tape A, and like gravity and all that. And then the initial conditions really are just the length, width, and mass of the tape, and the length of the tape is really just 20 centimeters. And we also have our constants. And the experiment was conducted by first beginning with a flat piece of tape on the table, in which case we pulled tape B off of that piece of tape to give it a charge, and then we held the tape B close to our hands to observe the charge, and then we held tape B up with symmetrical objects, and then we held another charged piece of tape A, close to it to observe the effects, and we found that our hands were negatively charged, so the tape is positively charged. And here are images of the experiment. And starting off our glow script code, we first have the constants and the variables and defining tape A and tape B in glow script. And then we found the force of gravity, which is just mass times gravity acting on tape B. And then we found the charge by setting force of gravity equal to electric force, and then assuming that the tapes have the same charge, which simplifies the Coulomb's law equation in down to the charge squared instead of the charge multiplied by each other, which is basically the same thing. And then we found the amount of electrons lost by doing the charge divided by the magnitude of an electron. And then we found the vectors from tape A to tape B and tape B to tape A. And then we basically just wanted to prove that the forces are equal and opposite. So we basically just assumed that after the function, and then we found the electric field of A on B and multiplied that field by the charge, and then it gave us the confirmation that the forces are equal and opposite. And here we have the results for code, which basically just show everything from earlier, which is that our charge is 9.3 times 10 to the negative 9 coulombs, and we lost 5.83 times 10 to the 10 electrons, and then just the electric force and the electric field. And then we found that there really aren't any noticeable differences between the computer model and the experiment, since they're pretty much the same. The only possible source of error we can really say are just human error and just approximating the tapes to have the same charge, which is mostly true. And our magnitude, we stated that on a previous slide, and then we don't have to worry about air resistance because F net is 0. And yes, we did assume that the tapes were point charges, and assuming that the tapes had the same amount of charge allowed us to simplify the Coulomb's law equation. And if electrons and protons had opposite charges, nothing would change because opposites would still attract and like charges would still repel. And it's important to handle the tape with care so that way you don't accidentally mess up the charge. Thank you for watching.